Okay, let's start with the chapter 1. Okay, the chapter 1 and 2, we talk about the water. Okay, so as you can see in the lesson plan in the previous video, okay, we have the water as a big topic, and then we have air, okay, air quality. Then we have the solid, okay, solid management, and lastly how to do the report, okay, on and also the under the EIA report, and also the schedule waste. Okay, so this is all the environmental engineering subject is all about. Okay, okay, let's start with the water quality. uh, Before we do the water treatment, so you should know what is the definition of the water quality. Okay, so we expect that at the end of this chapter, you should be able to understand the hydrological cycle of water. Okay, explain in details the physical, chemical, and biological parameter. Okay, understand how to measure the physical, chemical, and biological properties, and define the standard A and B. Okay, what is standard A and B actually? So the standard A and B actually is set by the government. Okay, of course we are going to have a different standard for A value and also B value. Okay, we are going to look the standard A and B at the end of this chapter. Maybe this one will be discussed in the next video. Okay, because what I'm going to present now is the first video of chapter 1. So it means that for chapter 1, I will give you 2 videos. Okay, so this is the part 1 video. Okay. Okay, example standard 1, standard A. Let's say the BOD, biological oxygen demand, at 20 degrees C. If for standard A, okay, you cannot, the maximum value for standard A is 20 milligram per liter. But if standard B can exceed up to 50 milligram per liter, that is the maximum limit. Okay. Okay, similarly, if you have a oil and grease, okay, for if standard A, the limit you should not exceed 1 milligram per liter. But if you go for standard B, the oil and grease, the maximum can be up to 10 milligram per liter. So when to use standard A and B will be discussed at the end of this chapter. Okay, you cannot apply both. You have to choose either A or B, and depending on the situation and what you are measuring. Okay, I'm sure that for hydrological cycle, this one you have learned during your school. Okay, okay, we have, for example, you have from the ocean, you have the evaporation, okay, and then the water convert to air, and then change to cloud, okay, and then we have the precipitation, okay, the raining, okay, and then from the precipitation, say the water from the rain, it is either it will become runoff back to the ocean, or it will penetrate into the land, okay, or the soil. And then we have the percolation, okay, water table, and also lastly we have the groundwater flow, and finally back goes to the ocean. So we should have the hydrological cycle. So I'm sure this is not the first time that you come across with the hydrological cycle. Okay, so you should be able to draw this cycle. Okay, impurities of water. So the thing is that, okay, because I know environmental engineering is a reading subject. So what I have in the slide is that I just highlight the key point. Okay, for your information, to answer the question, for example, during your MTA, okay, the most important thing is that you have the keywords. Okay, so we don't care how you elaborate the for example, for the definition, but as long as you have the keyword and the meaning is there. Okay, so you don't have to, for example, memorize word by word from this slides, okay, in order to answer for the definition. As long as you understand the keyword is there, so we don't have problem to give you full marks in answering the MTA later on, okay, because we don't have the final exam. Because last time we have the final exam for this engineering, environmental engineering, but this time there is no MTA anymore. Sorry, there is no final exam anymore, just MTA. Okay, so the thing is that, okay, in my slides, I usually like to highlight maybe with underlines or different color to show that there is a keyword that you have to remember. So the rest, you can create the sentence as long as the meaning is there. Okay. Okay, so let's look about the impurities in water. Impurities of water can caused by the surface, okay, liquid water travels. Okay, this one we have looked into hydrological cycle. Maybe it comes from the human activities such as industry and domestic waste, okay, agriculture, chemical, and the impurities can be both in suspended and also dissolved form. Okay, so we are going to look what is suspended means and dissolved means. Okay. Okay, usually the suspended material consists of particles larger than molecular size. Okay, they are supported by buoyant and also viscous force within the. Okay, whereas the dissolved material consists of molecules or ions that are held by the molecular structure of the water. So what is the colloid then? Okay, just now we have looked into dissolved. Okay, dissolved definition, and we have to also the suspended definition. So the colloid is somewhere in the middle. Okay, so the condition is that it is between the dissolved and also the suspended. Okay, so now what is colloid? Colloid are very small particles that technically suspended but often exhibit many of the characteristics of the dissolved substance. So it means that it can be part of the suspended and it is also part of the dissolved substance, but it often exhibit more to the characteristic of the dissolved substance. Okay, so it means that it is go more to the left hand side, to the dissolved part. Okay, just now we look into the water. Um, sorry. Just now we have looked into the water sources. Okay. Okay, and then the next part is the water pollution. Okay, water quality. You need to know what is the difference between water pollution and also water quality. So the keyword is that the water pollution is defined as the presence, okay, in water of impurities. Okay, whereby the water quality is predicted on the intended use of water and a gross determination of the quantity of suspended and also dissolved. Okay, so make sure you highlight what is the keyword between the definition of water pollution and also water quality. Okay, standard method for the examination of water and wastewater. So for your information, these are the common word if let's say you are dealing with the wastewater subject. Okay, standard method, it can be standard A or standard B. Okay, this is actually the analytical procedures that quantitatively measure. Okay, we have actually we have a textbook very thick. Okay, it will detail out all the procedures, for example, how to conduct the BOD test, COD test, the JAR test, TSS, and so on in detail. Okay, usually we do have this book in the lab. Okay, but I'm not sure now, but last time we have this book in the lab. Okay, for your reference. Okay, the water quality can be described into 3 parameters. Okay, we have physical, chemical, and biological. But in the first video, we just talk about the physical. And for the chemical parameters, we just cover only half of it, 50%. Okay, so another 50% and also biological parameter will be discussed in the next video. Okay, so now for the first one, okay, for the suspended solid, okay, this is the first one. Okay, so for solid suspended in water may consist of inorganic or organic, or if it is called immiscible liquids. Okay, what is immiscible liquid? Immiscible liquid means you have 2 liquids that cannot be mixed. For example, if you have one beaker consisting of oil and water, so no matter how many times or how hard you try to mix it, okay, whether you use the spatula, okay, to mix both water and also oil, so it will never mix. So that is called as a immiscible liquid. Okay, the liquid immiscible liquid means the liquid will never be mixed as a one phase. Okay, sources of suspended solid. It can be from natural contaminants. Okay, maybe it can be from human use of water. Maybe also can come from industrial use. And the result contain inorganic or organic and also immiscible liquid. So just the same thing, the repeating. Okay, what is the impact of suspended solid? Okay, so it may be degraded biologically and also it can cause disease to the organism. Okay, when we talk about suspended means, let's say you have a one beaker, you have this suspended solid. When let's say you just wait for 20 minutes or 30 minutes, you will see finally we have the solid part at the bottom of the beaker, and you will have a part of a liquid on top of the solid. Okay, so the solid at the bottom, when you try to filter out in order to separate the solid and also the water, so the solid itself that you get is called a sludge. Okay, so that is why in the definition here, solid removed by settling and separated from wash water are called the sludge. Okay, which may then be pumped to drying beds or filtered for extraction by additional of water. Okay, so this is known as the sludge cake. So it means that when this sludge, okay, when you pump the sludge to the drying bed or filtered, okay, and then you extract it by additional of water, or the name of this method is called as dewatering technique. So the dry sludge that you get finally, okay, the dry sludge, because the initial sludge that I'm talking just now is the sludge that is still wet. Okay, but when the sludge is dry enough, okay, it is known as a sludge cake. Okay, so how to measure this sludge? Okay, usually it can have so many tests. Okay, whether you can measure for total solid, TS, or suspended solid, SS. Okay, and also you can calculate for dissolved solid, DS. So what is the difference then between these three? Okay, total solid usually is the mass that remain after the evaporation. It means that after you dry it in the oven for 104 degrees C, so it is the weight, okay, the weight that you measure after the evaporation in the oven, okay, after you cool down and wait. So it is called as a total solid. Okay. Okay, meanwhile, for the suspended solid, okay, you filtering the water, drying the residue and filter to a constant weight, also at 104 degrees C. So this is called as a suspended solid. Okay. So lastly, determine the mass, okay, of the residue retained of the on the filter. Okay, the unit is milligram per liter. Okay, this is the unit of concentration, mass of solid basis. Okay, and the next one is the third one is the DS, dissolved solid. DS is actually the difference between TS and also SS. Okay, the organic content you can also calculate from the suspended solid. Usually, how we measure it? By firing up. Okay, by firing ataupun heat up. Okay, you heat up the residue for 600 degrees C, very high temperature. Okay, for 1 hour. Okay, then after you heat up, you cool down, and then you measure, so that is where you get the organic content. Okay, so for the filterable residue and non-filterable residue, what is the difference? Okay, firstly, you should know that both of these terms is used to represent the SS and also DS, suspended solid and also dissolved solid. Okay, the filterable residue is closely related to DS, and non-filterable residue is more closely to the SS. Okay, what is the use of suspended solid? It is a very important parameter for wastewater. Okay, it means that you can calculate what is the SS for influent. It means the initial value. And also you can also calculate the SS for the effluent. It means the final value. So you have the SS for initial, you have SS for final. Okay. Okay, turbidity. Okay, when we talk about turbidity, it is a measure of the light transmitting properties. It means that if you are given the one beaker containing the wastewater, for example, from the drain, okay, we want to measure how clear the water or the solution is, okay, Okay, how much light can be transmitted into the beaker. Okay, so this is another word of translating the turbidity. We want to check how clear the water in solution is. Okay, so why there is a difference in light transmitting? Maybe it is due to the presence of suspended materials such as clay, organic material, plankton, or other particulate materials. Okay, so how does this light transmit? It is either absorbed, AB, absorbed or scattered. Okay, it is not a direct quantitative measurement of SS. Okay, what is the sources of turbidity? Okay, maybe it results from the erosion of colloidal material. Maybe it can come from vegetable fiber or microorganism, or it can be also from household and industrial wastewater, maybe from soap, detergents, and also emulsifying agents. So these are the sources. If maybe in the exam you can give 2 or 3 examples. Okay, you may pick one of these to give as an example of sources. Okay, what is the impact of this turbidity? So just imagine if, let's say, you have a very dark, okay, dark wastewater, meaning the turbidity, the color is very dark. Okay, so the impact is that we have the undesirable taste and odor. Okay, difficult to disinfect because it's very dirty. Okay, may impart a brown or other color for water. Okay, and then it can also cause the sediment deposit. Okay, that can affect the flora and fauna. So this is more to environmental effect. Okay, how you measure the turbidity? Okay, usually we will use Jackson turbidity meter. This is the name. Okay, how you use it? Okay, determine the percentage of light. So we want to check how much the light can be transmitted, okay, into the solution or the water or the wastewater. Okay, so how this light transmitted? It is either absorption and also or scattering, as I mentioned just now. So what is the difference between these two? Okay, for dark substance, okay, absorption usually for dark substance, very dark solution or wastewater. Photometer measure the light intensity on the side of vial. Vial means, let's say, you want to test the sample, and then you put the sample in the vial, okay, and then you test in the turbidity meter. Okay, so it is opposite from the light sources. Okay, the way how they measure is opposite from the light sources. But for scattering, the degree is 90 degree. Okay, the degree is 90 degree from the light source. Okay, unlike the absorption, the degree is opposite from the light source. Okay, maybe 180 degree. Okay, the unit for turbidity, this is the most common, called as the NTU or nephelometric turbidity units. Okay. Okay, so turbidity, when you know the turbidity is good, okay, so it means that it is pure water. Usually the color will be colorless, pure water, okay. But when you have the wastewater which is darker, so we can measure the turbidity. So the apparent color of water partly due to the SS, suspended solid. The true color whereby the color contributed by the DS. So these are the sources of the turbidity. Okay, what is the color? Okay, sources means what is the indicator of turbidity? So maybe it can be yellowish brown. Okay, so this is more to organic debris. So the second one will be the reddish, maybe caused by iron oxide, or the color could be brown or blackish, maybe from the manganese oxide, or the last one will be the industrial waste, whereby we have the, usually industrial waste, we have a textile, very dark, we have the dye, and so on. Okay, the next one will be color. Okay, what is the color of impact? Okay, unsuitable for laundering. Okay, affect the market of domestic and industrial company. Okay, and usually the color will give the carcinogen impact. Okay, usually when we have the chlorine inside of the wastewater. Okay, what is the use of the color? Used in the potable water analysis. Okay, indirect measurement of humic substances in the water. Okay, usually not included in the wastewater analysis. So it means the color, some of the research might need color as a measurement, but not some of the research might not use color as a measurement. Okay, so it depends on what is your purpose on doing for a particular research. Okay. Okay, so how to measure this color? Usually we use special spectrophotometric techniques where the unit is TCU. Okay, but for color, it is a very special case. Once you collected the sample should be tested within 72 hours of collection. Because after 72 hours, we will expect there is a biological and also chemical impact, okay, during storage. So the result after 72 hours will not be accurate. Okay, so it means that you have to test the sample within 72 hours to get accurate result. Okay, test and order. Okay, what is the sources? Okay, it can be such as mineral, metal, salts from the soil and products from biological reaction and so on. Okay, and then it can also come from inorganic substances, alkaline materials and metallic salts, and also the organic material. Okay, and then what is the impact of taste and odor? So usually it will give you the displeasing, okay, displeasing the taste and also odor, and it can cause also carcinogenic. Okay, so how we measure it? Because it is just taste and odor, right? We can just direct measurement of the material. Okay, but we have a specific equipment to have the odor test. Okay. Okay, for example, measurement using the GC and also LC. So GC, for example, the gas chromatography. Okay, what is the unit for taste and odor? So we have the TON, threshold odor number. Okay, what is the recommended by Public Health Service? Make sure it cannot exceed 3. This is the number or the standard set by the government. Okay, serve as a guideline for potable water. Okay, temperature in almost all research, okay, temperature is very important. Okay, because it affects on the chemical reaction, aquatic life, solubility of gases. Okay, and then what is the source of temperature? It can be from the ambient temperature, discharge from industry, removal of forest canopies, and also irrigation of water. What is the impact of temperature? I just take the most important. Okay, if, for example, if temperature is increased, biological activity is increased. Okay, and fish are affected by the temperature and dissolve oxygen level. So it means if you increase the temperature, okay, so it might affect the fish. Okay, solubility of gases decreases at elevated temperature. So it means that if the temperature of the water is increased, so the solubility of gases decrease. So it means that less gas will be soluble in the water. Okay. Okay. So we finished the physical parameters. Now we move to the chemical parameters. So as I was saying just now, chemical parameter features touch on 50% on this first video. Okay. So we go to basically for chemical parameters we have inorganic, so organic. So we start with organic first. Okay, so the first one is the TDS. Okay, which is just now we have looked into SS, DS, and also TS. Now the next one, the next one is the TDS, total dissolved solid. So the material remaining in water after SS removal. Okay, what is the sources of TDS? Okay, the dissolved material result from solvent action of water on solid, liquid, and also gases. And also it can come from organic sources where we have the decayed product, okay, from organic material. Okay, and it also can come from inorganic sources, for example, minerals, metals, and gases. Okay, product produce undesirable substance in water in terms of odor, taste, and also. Okay, what is the impact of the TDS? Okay, so it can cause displeasing color, taste, and also odor, and it can also give you the toxic and carcinogenic. Okay, so how we measure the TDS? Okay, just simple evaporating to the dryness. Okay, we just evaporating the evaporating the sample, okay, until it dries, and then which has been filtered to remove excess, and then lastly you just weigh it, okay. And then the unit also the same as just now, milligram per liter, as SS, DS, and also the third one, okay, DS. And then for organic and inorganic fraction can be determined by firing, okay. Remember, the firing means you heat up, okay. What is the difference between firing and heat? Usually when we talk about firing, it means that you heat up at a very high temperature, okay. So for example, the temperature used here for the TDS is 600 C. Okay, the next part is alkalinity. So alkalinity defined as quantity of ions in water that will react to neutralize the hydrogen ion. Because you know the acid and alkali, okay, or base will produce the salt and water, okay. So the measure of the ability of water to neutralize the acid. Okay, what is the sources of alkalinity? Okay, we have carbonate, okay, hydroxyl, okay, hydrogen phosphate, ammonia, and so on. Okay, these are the sources. And then the dissolution of mineral substances in soil and atmosphere. And then it can also come from the phosphate due to the detergent wastewater discharge. And it also can come from the product of microbial decomposition, such as H2S, hydrogen sulfide, and also ammonia. What is the impact? Okay, alkaline, you know, alkaline is a base, very bitter taste. And it also may produce the precipitate due to the reaction between alkaline, okay, in the water. Okay, how to measure the alkalinity? Okay, all of you know this. During the school also you have learned about the acid and base, okay, or alkaline and also acid. Okay, by titrating the water with an acid and determine what is the hydrogen equivalent. So the unit is milligram per liter of calcium carbonate. Okay, hardness. Okay, we talk about the water hardness. Hardness is the concentration of multivalent metallic cations in solution. Okay, usually we consider at supersaturated condition, for example, the hardness cations will react with anions in water, okay, in order to form a solid precipitate. Okay, so under the hardness, we can divide it into two categories. One is the carbonate hardness and another one is non-carbonated. Okay, what is carbonate hardness? It is hardness that equivalent to alkalinity. Okay, whereas the non-carbonated hardness, it is called as a known as a remaining hardness. So what is the sources? It can be abundant or little. Usually for the hardness of water, the most abundant is calcium and magnesium ions in water. But the little constituent for the hardness of water might come from the iron, okay, manganese, and so on. What is the impact of the hardness? It can cause to economic loss to the water user, and also it can cause the losing of surfactant properties, okay, when stick to the surface of tubs, okay, it may stain the clothing, dishes, okay, and pore of skin, okay, feel rough and also uncomfortable, and also falling factor, okay, the boiler falling of water heaters. This is usually occur in the water heaters. We call as falling factor, okay, we have the blockage and so on. Okay, how to measure this hardness? You use the spectrophotometric technique. Okay, the chemical titration using the EDTA and also EBTS indicator. So this is the solvent that we use. Okay, to determine the quantity of calcium and magnesium of ions. Because as I was saying just now, calcium and magnesium exist as the most abundant in the hardness water. Okay, what is the use of hardness here? For drinking water and domestic uses, and also for industrial use. So the water hardness is very important in the measurement, okay, because it can cause the falling factor. Okay, the next one is the fluoride, naturally found in the surface water and groundwater, because this is the common one. Okay, it is very toxic in high concentration, but it will give you benefit in low concentration, both to human and also animal. Okay, these are the categories. Okay, for example, 1 milligram per liter in drinking water had to prevent dental cavities. If you use more than 2 milligram milligram per liter, it might cause discoloration of teeth. Okay. If you use more than 5 milligram per liter, results in bone fluorosis. Okay, this is the example of beneficial and also disadvantage. Okay, for the metal, I think this is the last part for the part 1 video. So the metal, all metals are soluble to some extent only, okay, in water. So the toxic metal, okay, it can be very harmful even in small quantities. Toxic, toxic, it means whether if you have a very small amount, also it can cause very toxic, very harmful to the human. Okay, what is the sources of the metal? It can come from the dissolution from natural sources, discharge from industry or domestic, and also from agricultural wastewater. So how do you measure this metal? Usually we use AAS, known as atomic absorption spectrophotometry. Okay, we do have this equipment in our lab. Okay, AAS is very big equipment. Okay, so under this metal, we categorize as non-toxic and also toxic. Okay, we go for the first one, non-toxic first. Okay, non-toxic metals. Okay, for example, hardness ion, calcium and magnesium. What is the commonly found in water? We have sodium, iron, manganese, aluminium, copper and also zinc. And Na or sodium is the most common and highly reactive because it comes from group 1 element. Okay, from your periodic table. And then for the salt of sodium are very soluble in water. Okay, and then these are all the non-toxic. Okay, sodium is corrosive to metal surface. Okay, because it's from group 1. Okay, iron and manganese in small amount cause color problem. Okay, and copper and zinc are very synergetic. But if copper and zinc appear in both, okay, both present at the same time, it can cause toxic, okay, to many biologicals. Okay, and then the last slide for today, for part 1, okay, for toxic metal, very harmful to human and other organism in small quantities, as I was saying just now. These are the example. We have the AR, BA, CD, CR, okay. These are the most common, okay. The mercury especially, this is very, very dangerous, mercury. Mercury, cadmium from the battery, okay, chromium, okay, argentum and so on. Okay, the cumulative toxins such as argentum, cadmium, okay, and the mercury are particularly hazardous, okay, concentrated by the food chain, thus posing the greatest danger to organism. What is the sources from the toxic metal? It can come from mining, industrial, and also agricultural, where it is a very big industry, a big main produce, okay, in Malaysia. Okay, so this is a very big industry. Okay. Okay, so I guess this is the end of the first video. Okay, so as I was saying just now, we are going to have another part, okay, or part 2 video, okay, to finish up the chemical parameters part and also the biological part. Because in the biological part, we are going to have the example of BOD calculation. But I would prefer the BOD calculation. We will discuss it in the class. So it is better for you to see how the calculation of the BOD. Okay. Okay. So with that, that's all from me. Okay. For now, for first video. Okay. Thank you very much for your attention. Assalamualaikum.